Okay, so welcome to our first remote learning experience, I guess you could call it. From each day forward right now, we're going to try to make a tutorial video on each of the lessons that we would do. I'll take you through a normal lesson. We'll have an aim, we'll have the do now. I'll go through some of the problems. I'll try to teach you some things, and we'll do the very best we can. Now, you see I still have the homework posted at the bottom of the screen. That's still there. Boom. We still have the same aim. And there's also a do now. So you can take notes right into your notebook. I'm not going to be checking that, but what I will be doing is checking the homework each day. So we'll talk a little bit more about that. You can read that in some of the announcements. All right, pause the video right now. Give the do now a shot, and then I'll go over that. Okay, the do now is one of those partition questions that we were doing one of our last days in class. And it says point Q is on the line MN such that MQ to QN is 2 to 3. If M has coordinates 3, 5, and N has coordinates 8, negative 5, where is Q going to be? So first thing I want to do is first recognize this ratio they give me, and that's part to part. So that means that if the ratio is 2 to 3, I'm expecting when I plot this line that it should have a total of 5 parts when I take a look at its slope. So let's see. Let me plot 3, 5, 1, 2, 3, 1, 2, 3. Okay, that's M. N is at 8, negative 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's N. Connect those. And it looks like the slope, if I'm looking at this correctly, looks like it's down 1 over 2. Down 1 over 2, down 1 over 2, or excuse me, down 2 over 1. Down 2 over 1, yeah. And look at that. It's broken up into 1, 2, 3, 4, 5 parts. Okay, point Q is supposed to be in a ratio of 2 to 3. So point Q will be at the second section. So not here, but right here. That's point Q. So now it's in the ratio of 2 to 3. And that puts point Q at 1, 2, 3, 4, 5, 1. Choice 1. Remember what we said, 85% of these problems can be done by just simply graphing them, breaking it up into the right amount of sections, and then figuring out exactly based on the ratio where point Q should go. Okay, now let's move on to the lesson for today. Let me clear this screen. All right, today's lesson is about mid-segments. Should be very quick. Should basically not too difficult to figure out. We're going to look at the mid segments of two particular shapes, trapezoids and triangles. Now, right there you get the definition of what mid-segments are. All they are lines that connect the midpoints of sides of a shape. So in this picture, the first picture, you see a trapezoid. Point A is the midpoint of PS right here. Point B is the midpoint of QR. So when I connect the midpoints of opposite sides, it creates what we call a mid-segment. Same thing on a triangle. If I look at a triangle, D here is the midpoint of AB. E is the midpoint of AC. So when I connect them, it creates what we call a mid-segment. DE is called a mid-segment. Now, that mid-segment has special properties, which we'll talk about in just a moment. But, actually, the first one just came up here. In a trapezoid, the mid-segment is equal to the average of the two bases. What do you mean by that? Well, what that means is the length of the mid-segment is equal to the length of PQ plus the length of SR divided by 2. So the average length of the bases is equal to the length of the mid-segment. Now, in a triangle, DE, the mid-segment, is equal to half the length of BC, half the length of the side it's parallel to. So if, let's say, BC was 10, DE would be 5. In fact, let's go back and just do a quick example in the trapezoid. Let's say the trapezoid up here, let's say this was 6 and this were 10. The mid segment would be the average of those two. So 10 plus 6 is 16. Divided by 2 would be 8. So the length of AB is 8. Okay, so that's how the mid segment is found in those two shapes. Now what we'll do is, excuse me, we'll do some problems that involve those two, maybe a little bit of algebra, and then that'll be it. All right, at any time you need to, pause the video, stop and reflect on what we just wrote. Okay, clearing the screen, going to the next page. Okay. All right, take a look at the following trapezoid. Now, I know there doesn't seem to be a question associated with this. Hold on, I got to go back up a slide. But the question would just be simply solve for x here. All right, well, you'd have to know some stuff about the mid segment. We just learned that this value x is equal to the average of the two bases, 21 and 35. So x would be equal to 21 plus 35 divided by 2. 21 plus 35 is 56, divided by 2 is 28. So the length of the mid segment of this trapezoid is 28. Good. Now, if you're wondering why are those lines here, these lines here just tell us that this and this are equal in length, making this the midpoint, and that this and this are equal in length, making that the midpoint. So that's its way of saying that that's the mid segment without actually having to say it in words. Again, pause the video if you need to, go back, take a look at the notes we just took. We're going to move on to another one with a trapezoid still. We'll go into triangles in a minute. Okay. Another mid-segment question. This time they give us the mid-segment. The question is solve for x again. If you want to pause the video and try it on your own, you can. I'm simply going to go ahead and solve it. Okay, let me do it in blue this time. All right, the mid-segment, 15, is equal to the average of the two bases. Well, this time my bases aren't numbers, they're expressions, but no big deal. Okay. Now, let me combine like terms at the top. You end up with 5x plus 10 divided by 2. Now, I'm not going to divide this whole thing by 2. What I'm going to do is I'm going to multiply by 2 on both sides to get rid of that dividing by 2. The reason that I do that is because that expression, 5x plus 10, may not divide by 2 nicely. So it's easier just to multiply by 2 on either side and then solve the equation from here. Minus 10, minus 10, 20 is equal to 5x, divide by 5, x equals 4. And now at this point, if somebody asked me, what is the length of the smaller base? I would just say 4 plus 3 is 7. And if someone said, what's the length of the larger base? I would just go 4 times 4 plus 7 is 16 plus 7 is 23. So those are just some other questions that could be asked if someone cared to ask them. Again, I'll remind you, hit pause on the video if you feel like you want to stop and reflect and look at your notes. Okay, that's gone. Let's do a question that involves a triangle. I'm skipping that screen. Okay, I know there's no question here yet, so I'll deliver that question in a second. It just says that CA is 14. So I'm just going to highlight that. That's that whole thing there. CB, this whole thing here, is 12. And AB, this whole thing here, is 18. Now, what is the question? Here's the question. What is the perimeter of the smaller inside triangle? Oh. Okay, so if I want the perimeter of that smaller inside triangle, I need all the lengths of the sides of that inside triangle. Well, here's the deal. If AC is 14, then DE is half of that, 7. It's the mid-segment of that one. If CB, let me just choose a different color here. Let's do like purple or pink or something. If CB is 12, then DF is 6. And then finally, if AB is 18, then FE right here is 9. Okay, because all those are the mid segments of those sides. Now I combine all those up. 9 plus 6 is 15, plus 7 is 22. The perimeter of this smaller triangle is 9 plus 6 plus 7, 22 units. We don't know the units on that, so 22 it is. There you have it. Okay, use of the mid segments to find the perimeter of a smaller triangle within a triangle. All right, one more. At this point, if you feel like you really know this, feel free to stop the video. Here's one with some algebra, though, and that'll be the last one. Okay, here's my question on this one. My question on this one is, what is the length of XA? Okay, now, why don't we know XA right now? Because we don't know what X is. So we need an equation that we can use to solve for X so that we can plug it in and figure out the length of XA. All right, well, AB right here is half the length of this. So I could say that 2 times AB, 2 times x plus 1, is equal to 5x minus 7. And that might be the easiest way to think about it. You could say that 5x minus 7 divided by 2 is equal to x plus 1, but rather not deal with the fraction. Okay, so 2x plus 2 is equal to 5x minus 7. I'm going to solve for x here. That cancels. Let me add 7 here. Sorry, writing on the screen. It's not my best handwriting. 3x is equal to 9. Divide by 3, divide by 3. X equals 3. So now that I know x is equal to 3, I can substitute that in right on over here. 2 times 3 minus 2. 2 times 3 is 6. Minus 2 is 4. XA is equal to... All right, so there you have it. That's the use of mid-segments to set up some equations to solve for x, to find out different things in a problem. Okay, your homework tonight is going to practice this. I'll be available tomorrow to go over the homework, and there'll be a new video for you tomorrow as well. Great.